Okay, last example on simple frameworks. So on this first simple frameworks, we're going to look at this one that is having a roller inside. So this side is a fixed or a hinge side, and then this side is the roller side. So we also have to keep in mind that the rolling element here, or the roller. The roller support doesn't support a horizontal force. So if it doesn't support a horizontal force, that means all the horizontal force should be applied on the hinge side or the fixed side of the frame. So even this one, we are having a horizontal force which is 1 kilonewton, and this 1 kilonewton, it should be balanced by a force in the hinge side or in the fixed side. Because if we are having a force, a horizontal force here, remember these are rolling element. If they will start rolling, that means the whole frame, it will collapse. Or else if they can roll this side, the frame, it will be there will be a force, it will be subjected to a tensile force. If it roll this side, it will be subjected to a compression force, and then it will snap in the end. So if we are calculating this one, we have to start by calculating our support. So taking moment at L, start by taking moment at L. So if we're at L, that means we are having clockwise forces, which is going to be 2 multiplied with this 2 multiplied by 2 plus this force. Okay, this one will be anti-clockwise, and then this one will be anti-clockwise. So it will be equals to at L. Okay, we're at L, so it will be equals to 1 multiplied by the distance from this point to the bottom here is 1, which is 0.5 plus 0.5 is going to be 1, plus this r multiplied by the whole distance, which is 4. So the 4r is going to be 4 minus 1 all over 4. Therefore it's going to be 3 over 4, which is equals to 0.75. Okay, and then the other one at R, let's take moment at R. So let's say if you're at R, it will be clockwise forces, it will be L only. L multiplied by 4 will be equals to 2. Okay, let's say it's 1 multiplied by, okay, at R, this one, okay, it will be 1 multiplied by 1 plus 2 multiplied by 2. So it's going to be 5 all over 4, which is equals to 1.25. Okay, so then if we balances our force, if we add right plus if we add the right plus the left, is going to give us 2, and then the downwards forces are also at 2. If we are drawing the vector diagram, we should have the angle here. So if we have to start by calculating this angle and the angle inside. So to calculate this angle here, we're going to say this one is 2, and then this distance is 0.5. So that means the angle here, it will be the inverse of tan theta, the inverse of tan multiplied by 0.5 all over 2. So the angle, it will be equals to 0, it will be 14. Okay, so I'm just going to convert it in the number, so I will take 14, and then the whole side here, it will be the angle of, it will be 2 and 1 here. That is whole distance from this point to the bottom here. So it's 1. So if it's 1, therefore an angle is going to be tan, the inverse of tan 1/2, and then it will give us 27 degrees. So if it's 27 degrees, then we're going to subtract to find this angle inside. So it will be 27 minus 14, then it will give us 13. So that means the angle here, let's write it. Yeah, let's say the angle here is going to be 14, and the angle here is going to be 13. Okay, and then now let's draw our diagram. So before we start drawing our diagram, we said to balance the force, we say the upward forces should be equal to the downward forces. This force should be equal to downward. So even the right force should be equal to the left force. That means we should add a force here of 1 kilonewton going to the opposite direction in order to balance these two, so that this roller will not move, it will be fixed, right? Okay, so then we have to add alphabet. Okay, if we're going to add alphabet, we can say this side we can start at A here, this one will be B, C, D, and then we have E here. Use a scale of 1 centimeter. 1 centimeter equals to 1 kilonewton. Okay, so 1 centimeter equals to 1 kilonewton. So that means we are going to start our run at A. So let's say this point is A, which is this one. See, this is A. Then at A to B, we're having a force of 1 kilonewton going to the right side. So going to the right, therefore we can just add 1 degrees. Okay, then this is 1, yeah. Okay, which is going to be B. And then from B to C, we're having a force of 2 Newton going downwards. And then let's say this one's going to be 2 going downward. So it's going to be C. Okay, and then from C to D, we are having 1 going to the left, and therefore going to add this one. And then it will be D, this point. And then from D to E, we are having our right support. Our right support, you said, is 1.25. So if it's 1.25, it's going to be this 1 plus 125. And so it's going to be 1.25. And then let's just draw a straight line like this. So it's going to be 1.25. This is R. So this is the distance of R, which is going to give us E. So then from E to A is our left support, which is going to be 0.75. So 0.75, yes, that's 0.75. Okay, so now we have to draw our members inside. So if we're going to start at E, so if we're going to have E, let's add our another alphabet here from E. Then we're having F here, from F to G. Okay, so if we're going to draw this point from E to F, from E to F, we're having 14 degrees. 14 degrees. So that means from E here we're going to measure 14 degrees. Yeah. So from this point we have 14. This is 14. Yeah. 14. So we could draw this line from of 14. Yeah. Okay, so if you check, F is in line with B, but okay, with B, yeah, from B to F, we have the whole we have to consider the whole angle here, which is 27. So from 27, we're going to measure 27 from B, and then we just, this is 25, 26, 20. This is 27, yeah. Okay, and then we're going to draw this line from of 27 here, and then we're going to have this point up until it intercepts with our line here. So that means at this point we are having F here. Okay, so this it will be F, and then this side, okay, this is E and F, and then then we are going to draw another line from F to G. From F to G, we're having a straight line here. So that means we have to draw a straight line from F going upwards to G. And then if we check, G is at an angle with E again. So that means G is at an angle of 14 with E. Yeah. So and then we have to draw this 14 degrees and yeah, 14 degrees, and then to this is 14 here. Okay, and then we're going to draw a straight line from this point to this side up until it intercepts with at this point. So therefore here we are going to have G here. This is G, and then we have to draw it in bold here. This is going to be G, and then from G to D we are having the whole angle of 27. So you can just draw a straight line from G to D, and then this it will be your diagram, your vector diagram. So if you are having this vector diagram, then now we can read our point. So if you read our member, so like from say from E to F, from E to F we have to measure from E to F. Where's E? This is E, and then we're having 1.2. So if it's 1.2 centimeters, that means it's going to be 1.2 kilonewton. And then this side, if we this, it will be F and E, and then this one it will be DG. So DG it will be equals to 1.9. So if it's 1.9 centimeters, remember our scale, it was 1 centimeter is equals to 1 kilonewton. So it's going to be 1.9 kilonewton. So you do the very same thing to all the other diagram, yeah, to find all the members.